Okay, so welcome. This is a collaboration with Antti Törmäne, who is from the Japanese Go Association, and I'm Attila Egri, Nagy, and I'm going to talk about how to advance humans' understanding with the new deep learning Go AI engines. So, what's the sort of the attitude here? So for long, we had the humans creating AI. So that's the purpose of the AI research. And it's like when it's done, then it's like, well, yeah, we want to have humans use them as tools, but we want to bring in something else. It's like, okay, so once you have a superhuman AI in anything, can you learn from it? And why do we want to do that? Well, it's like, okay, our sort of goal is the deepening of human understanding as opposed to creating more capable AIs. So why is that? Well, because we have to grow as a species. We will have the next pandemic, the climate change. So we need to be able to solve problems. And I was like, how to do this? Well, we follow the standard methodology. First, do something very easy, just concentrate on the games, just like in producing an AI, an artificial intelligence entity, we first concentrated on the games. So that's what's the role here. Just like as can be as personal development, if you want to be a good decision maker, then it's a good idea to start playing a board game. And also on the societal level, now we have the Go community who went through this very sudden transition from like not having AIs, just laughable ones, and suddenly superhuman. And it's like, well, mankind as a whole is likely to go through a similar phase. So talk about the game of Go. I mean, this is an international conference, so I think I cannot really assume that everyone knows that, but I have a very quick metaphorical introduction to the game of Go. So in real life, how do you build a house? First, you buy the land, then you get the permission to build something, then you start building. Okay, it's important. You have to own the land before you start building. In Go, the land is yours if you can build on it. Okay, so that's sort of the quick introduction and metaphorical. I'm not going to go through a 15 minutes introduction, but let me just do a quick one instead. And I'll switch to the camera. Okay, so what is the game about? The game about surrounding territory. So I will show you a very simple game. It's a very unreal. You will never see anything like this in real life. So black moves here saying that, oh, this is mine. And then white moves here. Okay, this is my side. And they very peacefully, that's why the game is not really credible. They build a wall. Okay, so by building this wall and sailing it off. Okay, so now this is white's territory, and this is black's territory, and if you count, well, you get 16 points here, and 12 points there and 12 points there, so that's a sort of a draw. So that's the purpose of the game. Of course, as I said, this was a very, very unrealistic game, because usually you move like this and you start attacking, and it becomes a fight. And there is another rule that if you surround your opponent fully, then you remove that stone. So that's another way to get territory. Okay, so that's, I haven't told you all the rules, but these are basically the basic ideas. Okay. So I'll just get to the point. So what is the biggest difficulty in Go? That's positional judgment. And that's like, that's the same for chess as well, but it's maybe a bit more difficult in Go. It's just your task is to look at the board and can you tell who is ahead? Okay, so this involves sort of an intuitive sense, being able to see the future from just a few scattered stones. And to build this sense, well, humans have to go through decades of practice. Okay, so it's like, now I'm going to ask you to just do the exercises. And it's like, that's a totally unrealistic if you haven't played this one, but okay, so let's just practice this skill, positional judgment. Who is winning, black or white? Okay, well, yeah, that's a sort of a mathematical question, because it's like, okay, no stones have been played yet. So sure, I mean, we don't know for sure, but it's considered to be an even position. Actually, we have the commie, so this white gets a compensation for moving second. So it's like, we don't know whether it's black's games or white's games, but we try to make it as a draw, as close as possible. Okay, so here, who is winning? Well, it's not that difficult to see that, oh, black has so many stones on the board. Well, because this happens to be a handicap game when you have a weaker and a stronger player. But okay, here it's quite clear that black has the advantage. So how about this one? Who is winning, black or white? This is actually also a very easy one, because the game is finished. So all the boundaries are sealed. So you can just count how much territory they have. And it's white won by 10.5. Half is because of the commie. So how about this one? Who is winning, black or white? Again, without serious training, probably just, you don't have too much idea. But this is actually a fully balanced game. So it's like 50-50. It's really an even position. So how about this one? Does it look also a balanced game? But no, if you ask the AI, then it's like white has almost sure chance of winning. Black made a bad opening. How about this one? Who is winning? Well, again, it's like you would need to think a lot. That's like, oh, what's going on here? But it's slightly better for black. Okay, so this is the task. This was very difficult to do it with computers before AlphaGo. So as everyone, I guess everyone remembers this event, because this was sort of a world famous. So AlphaGo won against Lee Sedol. And but it's important that compared to Deep Blue, so where is the Deep Blue computer now? It's in a museum. Okay, so that was just dedicated for chess. But AlphaGo had this tensor processing units that is, used in the industry widely. It's a very wide range of applications. Probably less people followed this. A year later, there was the Future of Go Summit in China, where AlphaGo Master, slightly improved, scored 60-0. And at this time, the humans tried everything. That's what about if you put teams together, and they can consult? And then again, it's like this was not the end of the story, because AlphaGo Zero came on the scene, which did not use any human expertise. So previous versions, you just took the human professional games. It's like a neural network. The network learns. It's sort of a very soft database, generalizable database search. But now it's just only self-plays. And it's just way better than AlphaGo Lee. And still not the end of the story, because it's like, who cares about what Google is doing inside? They never released the software. I mean, they said how to do it. So people actually could do that. So 2019, open source Lilo Zero went superhuman as well. Okay, at that time, so I could have it in my office. This was my computer. Of course, it required some good computer to put together and it's a bit of software engineering knowledge, but yeah, I could have it. 2020, if you play online on a free server, after each game, you get the superhuman AI review straight. Okay, so it's everywhere. And that's a lot bigger thing, because it's like, well, winning against the world champion, fine, that didn't change my life. This changed my life in a sense that now I have a totally different ways of learning this. So what is this intuitive knowledge? I mean, if you happen to know the book by Daniel Kahneman, then I can say it's a system 1 and system 2, the hot cognition and the cold cognition, sort of the unconscious thinking and the conscious. And this, of course, the neural network, this positional judgment, that's system 1. And it's like you might say that, well, the search algorithm, it's sort of logical system 2, but it's actually not quite, because that uses the Monte Carlo algorithm. So it's very randomized. But we can rephrase the problem of learning from AI as bringing the system 1, the sort of intuitive knowledge, into the realm of logical thinking, verbalizing intuitive knowledge. So this is the famous move 37. This was in the first game in the Lee Sedol match, and this was considered to be creative. It's like, well, this was hailed as the moment when the machine showed some genuine creativity. And it's like, well, yeah, it's like, what does it mean to be creative in this context? If you think about it, it's basically the learning algorithm is just a huge filter on a random search, and it came up with this idea, and the people thought it super creative because they just never had this idea to attack a stone so far above, so far from the edge. But once this happened, it's like, well, people are playing it, and it's like, it works fine. So there is a bit of dogmatism in the human wisdom there. Okay, so, but, you know, after 2016, it's like everything changed. This is what the community says, and it's 2 phases. The first is just merely seeing that different moves, what was considered by humans good, could work as well. Immediately, they could try new ideas. And then, of course, what I said, the technology became available for everyone. And so that's a real revolution. And of course, in a way, humans are getting better in Go as well. This is the Facebook engine, and they tested the historical games as well. And I know this is debatable because it just says that, well, humans are playing more like the AI now. And it's like no one has a proof whether the AIs are close to the perfect play or not. Actually, you know, people would say that they are not close to perfect play because, well, you can just train another network longer and you get a better player. But okay, that's the key question. So how can we learn from the AIs? So this is how they communicate. This is what you can do. This is just one particular very simple piece of software. I took the board position before move 37, and it's like if the analysis is going on, this will tell you that, well, if you move here, that was the move, you get 51.1 chance of winning. So this is still balanced, but this is the best move, and this is good move as well. And this would say that, well, okay, this one is not so good, and anything else is probably just very bad. Okay, so the computer will not tell you that, oh, this is a good plan or anything. This just says that, well, this has the highest chance of winning. Or you can ask the computer to give you the estimated score. So of course, well, yeah, this is sort of averaged over the 0.3. So you will win by 1/3 of a point. And you can also ask for the principal variation. So what is the computer sort of thinking? What would be the most likely way of playing? So how can we use these tools? Playing against them? No, people tried, and it's like almost no one is doing that. Cheating with them? No, of course not. We don't do cheating. So what remains is learning from them. Yes, that can be done in 2 ways. It's like you can watch the self plays, and you can do analyzing games. Just a note on cheating, because that's a work we did before, and this is an enormous problem. It's especially in the pandemic, and it is a very tough problem, because while we can have different metrics now with these tools, we can calculate a lot of statistical information, and that can point that, oh, okay, this playing style or this strength is probably not human. But you know, this is not a hard proof. So you might it works best if you suspect that someone is cheating, and you go to the person and look, here is the evidence, we think you are cheating. And if the person says, yes, I did, then it's a clear case. If the person denies, then okay, that's the end of it, because this is sort of a statistical evidence only. So let's just think about when is learning possible. So this is just a very common sense way of thinking. So who can we learn from? So the teacher should know more. Otherwise, you know, what can we learn? And the teacher should be able to explain, and the student should be able to comprehend. So it's like this should be there. So AI as a teacher, the AI knows more. That's fine. That's superhuman. But the AI does not explain. It only gives probability score estimates. There is no planning, nothing, no story. And the student should be able to comprehend how. So that's sort of the key is in our research. And that's sort of the idea is that, well, yeah, we have to act as a scientist. Okay, so because natural intelligence, we like to think of in terms of the why questions and explanations. So as in science, we create explanations and test them by observations, experiments. In Go, well, it's a overall strategic plan that explains what's happening on the board, either your plan or the opponent's plan. And they are verified or falsified by the opponent or by the analyzing AI. So probably one of the best techniques you should do is that when you finish a game, you don't just look at what the AI says. You just go through and it's like, okay, can I find a better move? I did this in the game. It didn't really work. I think this is not a good one. Can I find a better one? So that's when you come up with a new hypothesis. It's like, oh, okay, this is a better one. And now you can ask the computer, it's like, wow, would this other idea a better one? But again, it's like you need to see that this is not what the computer has, what the AI has, but it's the human is bringing in that, having a question and the hypothetical explanation. So the active analysis, which is recommended, that's like a series of experiments. And it's like, you know, I'm not planning to write a novel, but I read all these books because I realized that, okay, it's very much part of humans thinking, just bringing a story. So it's like, what happens next and why? And that's very relevant in game analysis and in actually plan as well. And that's like, you realize, just as in a book, a plot is around a conflict or a trouble. So game reviews revolve around mistakes made. They are more interesting than steady, solid play. And that's why it's a bit more difficult to give a narrative to the AI self-play. It's like not making mistake here, not making mistake, and it's just a balanced game. And what's the story? So for now, still the most efficient form of learning is when you learn from a human master. Here's Michael Redmond, who is AI informed, using the AI to test his ideas, and based on that, giving a human form of knowledge. And of course, the underlying sort of the philosophical question is that how much learning is possible? How compressible is Go knowledge? So it's like, what would be the perfect knowledge? Well, if you have the full game tree and at each node, you know exactly the best possible score from that. And it's like, but okay, we will not have that because it just doesn't fit into the universe. And it's like, wouldn't fit into the multiverse as well. So that's beyond question. But if you think about it, the superhuman AIs is like 160 megabytes. That's the neural network size. So is this a good approximation? Is this a good way of thinking about that? This is the information you need to play well. And it's like, so how much of it is comprehensible? Okay, is everything comprehensible in this complex world of Go, or you will have something like, actually in chess, you will have some incompressible things, because in chess you can just check the end games, and there are some end games that like take, I don't remember, but like 200 moves, and there is just no logic in it. Just these moves you do. I mean, it's like there is no plan, but if you do that, well, then you can win. So that's where humans just draw, because it is not compressible. So that's the underlying question, and it's like, well, yeah. Again, let me just go back. So what is the motivation here? It is difficult to see the longer-term effects of AI technologies on our society and human beings, and it's like, that's why it's like, look at this simple thing. It's complex enough, the Go game and its community. So what's happening there? This might be sort of instructive to see what's going to happen for the whole society. And it's like, it's so interesting times. We have, I have access to really high-level Go knowledge if I want to analyze my games. It's like previously this was very, very difficult to have. You have to have a master and a face-to-face meeting. But of course, we have to play the role of a scientist. And that's like, yeah, if you just want to have one takeaway question, so what are the efficient methods for deepening our understanding when we have unlimited access to high quality statistical data? So that's the AI engine. So what can we do and what should we do? And well, yeah, that finishes my talk. Thank you very much.
Thank you very much. Very impressive talk, including many aspects. Please go ahead using your microphone. Any questions and comments?
Well, I think just unmute and ask.
Yeah, I cannot see. Please go ahead.
Yes, thank you very much for this interesting view on the event of the Go play and the beating of the human logic by the ANN logic. But in general, or for this particular case, strategical games like Go and chess, I would not emphasize that the AI taught us how to play. I would point out that it managed to break human mental barriers in playing and in thinking how to play, and allowed reorienting our priorities inside the probability space for Go movements. And that this was an example for a good impact of an ANN logic on human thinking logics. But I think we should bear in mind that the ANN logics are a fundamental new way of making decisions and of coming to judgments because of the mix, the superposition and the mixing of influences. So for the future, I agree with your resume that we do not know how we can judge the impact which this could have on our systems. But for science and for research on how decision making can work, I think that analyzing ANN logics could bring very nice new inputs of what is possible and what we should have to consider. Thank you for your presentation.
Yeah, thank you. It's just one quick remark. It's like I haven't mentioned the other way of using these AI engines. It's basically now you have a new master, and you have access to all neurons, right? So that's the feature map extraction. So that's another way to do that. So yeah, still a lot to extract from this. Thank you.